This is Simply Installing Ceph with Salt. And I'm Eric Jackson. I'm part of the storage team. And let's get started. Whoops. All right, I'm just briefly going to cover Salt and Ceph. Salt, you probably already know it's an automation framework. You can use it for configuration management. It is 5 years old, but it is still maturing. It is Python-based. One of the big deals about it is it has a message bus called 0MQ. There are others, but it's extremely fast. And the most common setup with Salt is a master minion configuration. What is Ceph? Chances are many of you already know what Ceph is. It's distributed storage. You've probably heard it to death, even in today's keynote. It provides object, block, and file storage. It is self-healing to a decent degree. You lose hardware, it moves your data around. And one of the better things is it can use commodity hardware and avoid the whole vendor lock-in. But today, I'm going to talk about, the top one's missing, lovely. Or it's merged over. Anyway, so if you've installed Ceph before, you've used ceph-deploy. So this slide's screwed up because the middle section is painted on the first one. But effectively, this is the web page from the Ceph website, which lists all the different things that you can do with ceph-deploy. Now, the issue with ceph-deploy is that it really is a tool. It's a utility. It is not a management tool. It's not idempotent. If you turn around and run certain commands and you rerun them, they fail. And it's up to you, the administrator, to know when to do that and when not to do that. If you do have a failure, it can be extremely painful to reverse it. If you've misconfigured some of your hardware the first time or your virtual machines and you got an IP address wrong or what have you, try reversing the monitor, the installation, taking yourself back without having to start over. It's a bit difficult. So as I said, it's not a management tool. And when we're getting to trying to manage Ceph, you're going to need one. Now, when I was showing this to other people, one of the steps apparently that I forgot was, why would I want to bother with Salt anyways? So I thought I'd just take one page and say, this is the current solution we have for Salt with Ceph4. In other words, that's all the commands. There are 6 stages, 0 through 5. I actually missed one on this slide, lovely. With one step in the middle that is creating the configuration file. And that's it. So when you stop and realize how many different steps you do have in trying to set up a Ceph cluster, this simplifies and minimizes quite a bit of it. One of the nice things about Salt is the individual steps are accessible. You can get to them. They're not hidden from you. But at the same time, they're not the focus, or they don't have to be the focus. So we're not just simply exchanging 3 dozen, 4 dozen commands using ceph-deploy, among other things, and just exchanging them and saying, here's another, 50 commands that you have to run in Salt. Now, Ceph Prerequisites. Ceph does have, a decent list. It really does need a time server. You may have, if you've had experience installing Ceph, the monitors will sit there and say they're skewed, but the data nodes need to be synchronized as well. They simply won't work if they are too far out of sync with each other. A public and cluster, and possibly even a management network. In the simplest configurations, yes, you can use the same network for all. But in a realistic configuration with real hardware, chances are your cluster network is separate from your public network. Role assignments. That's one thing you don't have with ceph-deploy. The whole idea here is you have machines that you want to be monitors. You have machines that are storage nodes. You have machines that are gateways or MDS servers. And then when you talk about disk and OSD assignments, Ceph is incredibly flexible, almost to a fault in that respect. You can have OSDs that are standalone, or you can have OSDs that are a data node or a data disk and the journal's on a separate disk. And then Ceph does have a configuration file. So the Salt strategy that I went with here was to do at least what ceph-deploy does for deployment and more. So to think about it from that way, many of us are coming from different places, different backgrounds. You could be using your own Pixie server, you could be using Vagrant, you might be in the cloud. As a result, depending on your environment, you probably already have a provisioning system. On the other hand, if you're in a virtual environment, you might not have any provisioning system. So the first thing to take care of is finish provisioning, whatever that happens to mean for a given environment. One of the next things is, for all the things that we just said Ceph needs, people would ask the question, doesn't Salt already have all that information? Doesn't it already have the IP addresses, device names, all the stuff I really don't want to have to go get? And it's like, yes. So one of the things we should do is we should ask Salt and go gather the data for us. In addition to that, because there is a decent amount of data, validate the configuration. Try to keep me from going off into the weeds. If you sit there and use ceph-deploy, it's not going to tell you that you've done something wrong. It's just, you know, you're going to find yourself in a bad place. Your Ceph cluster is not working the way you think it should, or you actually are getting errors. So we should do some type of validation. Then obviously the next part is actual deployment. And set up the monitors, set up your storage nodes. But one of the additional things, and ceph-deploy does do some of this, but probably not to this degree, is set up the reasons why you're using Ceph. It's like you wanted a Ceph cluster, usually just not for the sake of, you know, wanting a Ceph cluster. It's because you wanted CephFS, you wanted iSCSI, you wanted Rados Gateway because you're looking for a particular feature or capability. It should do this too. And then probably the bigger issue I would say is managing roles. It's not just about doing deployment, it's about the life cycle. Once you have hardware that you decide, you know, those are the small drives and I'm really not going to replace them, or I don't like that vendor anymore. Being able to take that equipment out fairly trivially. Or if you need to add more equipment and say, you know what, we only started off with 2 redundant gateways, but it turns out the number of clients we have now, we're going to go up to 4 redundant gateways. Make that as trivial as possible. So to do that, effectively just came up with a convention, naming convention, and called these stages. And there are the 6 stages. So at stage 0 through stage 5, I won't read them to you, but effectively they reflect exactly what we just talked about. One other comment to make is if you're familiar with Salt, you know that its defaults. It puts its configuration data in SRV pillar, and it puts its state files in SRV Salt. So to help with keeping that you might be using Salt for other purposes, we put all of our files in subdirectories of both of those. So SRV pillar Ceph, SRV pillar, or SRV Salt Ceph. All right, so on to the stages. So this is kind of a, I'm probably going to go through this a little fast, just to keep you guys not too bored. But effectively, it's a behind the scenes. It's showing the step-by-step. In other words, when you said, hey, I'd like to run stage 0, what in the world does that really mean? And it's split up into a couple pieces. So the first thing is it sets up the master. It syncs Salt components. There are certain things that if you're in a fresh install, there are certain modules that have been written, and those don't magically appear on all the minions. So that's the first step. Adding repositories. Currently, it does not add repositories by default, but the files have been put in place so that if you needed an example to use, it's available. Update packages in the kernel. This was one of the trickier parts, especially with Salt. Is, and I'll mention why in a second, but effectively bring all the packages up to date, effectively a zipper update. If the kernel has changed, reboot the master. Then mark this complete, and we'll come back to why that happens, and then wait for all the minions to come online. Because it is possible that if you're sitting here doing a test setup and you're doing a huge cloud installation, that your Salt cluster actually has not finished coming up, your minions themselves. After the master is done, do the same thing on all the minions. Now the nice thing here is this happens in parallel on all the minions. So whether you have 4 or 40, you're not going to be waiting for all of them to update serially. But it's effectively the same idea. There's a couple pieces added here that are slightly different, and this is, there's a queue created for that minion to effectively put put its name in the queue, and then at the very tail end of the process, take its name from the queue. And that's how I'm able to sit here and connect stage 0 to stage 1 for automation for those who are interested in it. Behind the scenes, it's using the salt reactor. But it does the same thing as far as syncs the salt components. Install the salt mines. Salt mines are effectively caching the results of salt modules, and we use them in a couple of places to save on repeated calls, not continually executing. Here, the basic example is HWinfo. If you had 24 drives on a system, you type HWinfo, let's say it takes a minute. You could, yes, it'll run in parallel on all the machines. You could run it 3 times, but there's no reason to really rerun it the second and third time. So for salt, and its terminology, you create a mine, it will cache those results, and we can use that. Same thing of adding repositories. I don't add any repositories by default, but the slot is there. And then update the packages in the kernel as well. And that is effectively the end of stage 0. Now, just to give you an idea, there are a couple of important files. There are more than one way to define the minion ID names, and there was not a guaranteed way to sit here and query Salt to say, can you tell me who the minion, what the actual minion name is? Because you can override this like 2 different ways. So I just said, all right, I'll create it for you as part of the RPM package, but if I'm wrong, this is the file you can edit and turn around and say, no, this is what I called my salt master. The orchestration file, that is one thing that I'm making heavy use of. If any of you are familiar with salt, you've probably heard about high state. In this case, I'm not using high state at all. Everything is orchestrated. Because the reasoning being this, I need to run so many commands on these machines, then I need to run commands on those machines. And even though some of those steps happen in parallel on individual minions, I need groups of commands to happen serially. And that's what salt orchestration does. So at the very bottom there, you see the 2 commands. Those are technically the same command. And in fact, we got into a bit of a, which was better, numeric or descriptive, so we did both. So if you actually say salt run state.orchestrate ceph.stage.prep, it runs stage 0. I happen to like to be lazy and use the abbreviation state.org and type ceph.stage.0 because that way if you're going through this process a lot, you're only changing 1 character. So feel free to use either. Stage 1, discovery. So quick word about Salt. Salt uses Jinja and YAML by default, and because of that, I stuck with it. I wasn't going to introduce any new renders or anything like that because I figure if you're visiting the Salt site, you'd like to recognize the same YAML files and the same Jinja. One of the issues, though, is in a traditional Salt setup, is you, the admin, are having to do a lot of typing. You really do have to put a lot of configuration data and YAML structure, and it could be 1 file or it could be many, into the pillar. And I have discovered that even some technical people are intimidated by YAML files and trying to get their indentation right. So this is part of the motivation of why I make the next decision. Salt also will complain about missing SLS files. It is not very forgiving about things that you say, I expect you to find a file with this name here based on a minion, and it doesn't exist. You will get, the nice red wall of text. And part of the sideline is automation is the goal. As much as people like to sit here and, click on something and have it do something, realistically, once you decided you trust a process, you typically are going to try to script it, you're going to try to automate it, you want to press less buttons, and if you could even get past that, you will. So rather than you having to go outside, make sure that Salt is actually able to handle the automation that you're probably going to want. So stage 1 is discovery, and effectively all we're doing here is collecting specific grains and mines. A quick word, salt grains are effectively just statistics about the individual minion. It could be the kernel release, the operating system number, network IP address. Mines are the results of modules. The modules are whatever is you consider more or less dynamic data. The reason I'm using it, the interesting thing, Salt does not find empty disks on a server. It does not have, even though there are certain commands out of all the modules they do not have one that actually met this requirement to say, can you find all my free disks? So I had to write one. So the steps, this is actually pretty short. It's wait for the minions, because especially in a virtual environment where you're sitting there banging on one disk on your one host, it's quite possible that you'll have a couple of minions that are a little slow to respond. And then what I'm calling it is populate proposals. So effectively, this is just a quick cache to sit here and say, hey, all that data that you were going to have to gather, all those device names for the disks, all the IP addresses, let's put all that output into a particular place. Now, this is just a quick showing you with a subdirectory. It's actually a bit bigger than this now, but nothing to be scared of. There's a bunch of subdirectories, and you'll notice one text file, the policy.cfg. Now, the policy.cfg effectively is going to gather all these fragments. I'm going to call them configuration fragments, but effectively they're just YAML files, and they're in the various subdirectories, and it will connect them all together. Now, I'm not going to go into detail about it right now because I figure that's too much of a diversion. We'll go into it when I complete all the stages. So if you can accept the fact that you ran stage 1, and then at this point you're going to customize this policy.cfg to say, hey, how do I want my Ceph cluster to really look? You know, am I doing dedicated roles? Am I doing shared roles? Am I saying I'd like this hardware profile on all these machines in the rack, or I'd actually like 2 different types of hardware profiles? The orchestration file is srv salt ceph stage discovery, and it's default.sls. So if you actually wanted to see what are the steps, you know, really behind the scene, you could. And to run the command, it's just as boring as the first one. State.org, ceph.stage.1. After you've created your policy.cfg, we're still in a quasi, not quite there yet. In other words, for the data to be ready for Salt to use to give to Ceph to control it, it needs to be in Salt's pillar. And even though you saw the proposals directory was under the pillar, it is technically not in Salt's pillar. So the configure step actually does that. It takes your policy.cfg, the fragments that were created during stage 1, and creates the proper configuration file that makes Salt happy. The simple steps here is it pushes the proposal that you've picked. It does a refresh of the pillar data. Something I'll allude to that I'll tell you about in a moment is I'm using an external pillar, and that's why we do add missing configuration data, key regeneration, and then we refresh the pillar data again. Pillar data in general cannot be used to make decisions about other pillar data, but because of something else I've chosen, we can. And I think you guys will find that useful. Just to tell you where things are here. So the 2 places the configure writes is srv pillar ceph cluster. It takes care of the cluster assignment and the role assignment. And the other files, the ones that would be more related to IP addresses, devices, and the relationships in the OSDs, are actually stored under the srv pillar ceph stack default. Now, the other directory that you see underneath that, the srv pillar ceph stack, that's your directory. In other words, if I get any of it wrong based on whatever, and you need to override anything at any level, that's where you would do it. And that, so stack, if you notice, it's like, why is the word stack in there? Stack is in there because Salt has this concept of what's called an external pillar. Now, in the normal sense, the original sense, the idea of the external pillar, somebody says, oh, I'm using Salt, but see, I have this CMDB, or I've got this other configuration manager, or I've got LDAP, you know, and I've already got data there. Can I bring that data into my Salt configuration? And the answer was yes. Then, unfortunately, I do not have the author's name memorized, but I was shown this at the Salt conference it was actually this year. somebody wrote a external pillar as a Python module, and effectively it uses YAML files, but these YAML files can then use content that's already in the pillar to make other decisions. So that's why we actually went with this. To give you, if I had to try to summarize what that is, imagine if you had an rsync that actually could read YAML content and do the right thing, as in merge my list together, take my dictionaries and put the keys right. Oh, but if it's a key that's already specified, then overwrite that value. That. By the way, it is automatically included in 2016.3. That's why I didn't have any fear of using this, even though we're shipping 2015.8.7. But it's going to be part of Salt proper, and we'll eventually move it out of our package once we're up to that point. The actual configuration file is what you see there, the modules.conf. So effectively, I'm just pointing you to everything behind the scenes in case you were sitting here digging and trying to figure this out. Now okay, you can see all that. All right, so this is a stack.cfg. It's not that hard, but I just wanted to sit here and cover it quickly. It looks intimidating because, you know, there's a lot of text. But the reality is that when you go to define variables for various things, you don't necessarily want it affecting everything. So there's a global file. This would affect every minion in your Salt cluster. There's a cluster.yaml. This affects every minion in a Ceph cluster. I've been alluding to roles. We use roles heavily. If you have a monitor role, a storage role, a Rados Gateway role, then, and for some reason you need to define something unique to it or to those machines, that's where you do this. Ceph.conf is a special case at the moment that's in here. I may be removing it in the future because now I've figured out how to do things with Salt that I didn't know how to do at the time that I was writing this. And then finally, if you do have that special snowflake, if you do have that one server that is unlike anybody else and you need to have it do something different, you can configure it. You can actually add the configuration parameters to its own file. So, wrapping up stage 2. This is the orchestration file, and you can see it's the same command again. Salt run state.org ceph.stage.2. Everybody okay so far? So we've only gone over 3 stages. Stage 0 was prep, or complete the provisioning. Stage 1 is discovery. Go find my stuff for me. At the end of stage 1, you have the one interactive part. I need you to tell me what your Ceph cluster, what you want your Ceph cluster to really look like. Stage 2, take that data and configure the Salt pillar. And then the whole point of why you're actually doing this. Give me a cluster. So that's stage 3 in deploy. Monitors, if you're aware, if you've got any experience with Ceph, you know that they manage the map of the cluster and they have a quorum with Paxos. You need a majority for your Ceph cluster to keep working. Storage, you can use all sorts of storage. This is one of the good and bad things in Ceph because it's like, yes, you have the freedom to choose a lot. You have SATA drives, SAS, SSDs, NVMEs, and then even between those, if you have different models of drives, you can use one drive as a data drive and use one of the other media as a journal drive. And then the proportion of data drives to journal drives, well, you can change that too. So there's a significant things you can do here. All right, so just to give you a quick rundown of what's going on behind the scenes. So what happens when you say, oh, okay, I've got all my configuration, now run. The first thing we do is actually, is a ready check. And then validation, and then time sync, and I'll cover these really quick. The ready check, all I'm doing is checking that your firewall may be configured. I'm not doing anything too fancy right now. This is basically to help you that if you're in a virtual environment, or you're in a POC, and you've told yourself and you said, oh no, I've disabled the firewall, I'll at least give you a warning to say, no, the firewall's not disabled on node 6. So that way you save you a little bit of headache, but it doesn't fail at that point. Now the validation does have some minimum requirements because this is part of the product, and so we've said you have to have 3 monitors, you have to have 4 storage nodes. Now technically those could be the same. Now I know if you've set up Ceph, you know you can get away with 1 monitor and 3 storage nodes, or even less if you're willing to tweak certain things. But since this was, generally speaking, going to be an install for either virtual environments, proof of concepts, or actual production, then we stuck with those choices. There's other sanity checks in here. If you actually have told me through your selection, your policy.cfg, that, oh, I'd like these to be monitors and I'd like these to be gateways, well, then they should have access to the public network that you also said as well. Same with the storage nodes. They have to have access to the cluster network. So if I see some things like that, I'll cause a failure. Time sync, it defaults to NTP. It's configurable. You can disable it as well. I skipped the install Ceph part because that is effectively just the zipper install Ceph. The next is the configuration, the admin keyring, and then setting up the monitors. The configuration follows what you know about Ceph. It's etc ceph, ceph.conf. In Salt, because we've configured Salt to control it, it will actually update it on all the minions that are necessary, everybody in that Ceph cluster. Created an admin role. This creates an admin keyring. And that admin keyring, it gives you keys to the kingdom. The only machine that needs it is the master. We've actually sat here and gone through the trouble of removing it from all the other machines. However, if you're accustomed to ceph-deploy and you want your monitors to still have the admin keyring, feel free to put it on there. The monitors, just telling you where the keyring is actually getting created. It's under varlib ceph mon ceph-the hostname keyring. This is one of the things, if you've been used to ceph-deploy, you've probably had to dig into the code a little bit to figure out what's it really doing behind the scenes. And one of the goals here was to remove that magic. There's nothing hidden from you. You would be able to read a salt file, any of the SLS files, and it should look fairly obvious going, oh, you're simply copying this file from my master over to this location for the minion. And finally, the storage. Storage, of course, takes a little bit, a couple more steps. Anybody who's familiar with the Ceph disk prepare and the Ceph disk activate steps that Ceph deploy normally calls, we're doing something similar here. But we do have a couple of other advantages that we're doing with Salt for alternate default configurations. And finally, pools. So initially, when I did pools, I did not put, I put pools there as a slot in case you wanted to create pools. Maybe you're doing a POC, maybe you're doing, some kind of setup. At the moment, though, in the default, it will create a demo image for RBD, named, or the image name, I should have said that better, is called demo, and it's in the RBD pool. And this is purely to help that somebody who wanted to try out iSCSI and didn't know what to do, you'll get an iSCSI setup. But if you want to override that or disable it completely, you're able to do that. And that's what the bottom half of this screen is showing. If you're familiar with Salt, one of the things you'll know is that if you have a directory name / init.sls, that's equivalent of specifying a file, decided to use that as redirection. So now I'll say every directory. And every directory in this Salt setup, we have an init.sls that is pointing to a default.sls, and the actual work is happening in default.sls. This way, you can make changes to the Salt pillar and override what the Salt states will do, and you don't have to modify these files directly and then worry about an upgrade at some point and you having to reconcile the changes that you needed to make because we didn't have the right steps in there for you. One other piece that I thought I'd show this. The different steps that I've been going through, they can actually be called independently. Even though I've been showing you the orchestration steps, the salt run command specifically, and those are the higher level. If at any time you want to take control and you sit there and say, well, I want to do this myself, this is the equivalent. Because we've defined roles and we've defined, as monitor, storage, and admin. For instance, if you had gone out and removed your admin key, mistakenly from different minions, or somebody, your other administrator helped you out by manually copying it from another source. The last command there saying salt-I, it says use pillar data. I guess the I was supposed to look like a large pillar. Use your pillar data as a target, state.apply ceph. Oh, in this case, pool. The same would be true if it is ceph.admin. It actually would take care of the admin keyring. And back to the orchestration file. That's, stage, deploy, default.sls. And the third command, just as boring as the rest of them, ceph.stage.3. Now, why are you wanting to use Ceph? Now, you have a question?
A question about the deploy stage. You mentioned that you have the ability to create pools at that point.
Yes.
But do you have the ability to modify the crushmap if you need, for example, the ratio?
I don't have a nice crushmap. Put it this way, we wanted to do the crushmap this time. So at the moment, yes, you still have to do the crushmap yourself. So sorry about that. It is quite honestly the time issue. But we have sales engineers begging for the same thing, so I think it's going to be on the list immediately. But not sure if everybody is aware, but SES 4, our Gold Master candidate is this week. We're releasing December 1st. So we had a deadline in addition to SUSECON. For the services, how did you want to use Ceph? You might want to use CephFS, you might want to use iSCSI and Rados Gateways. The CephFS steps are pretty simple. If you've done it by hand, you're creating a data pool and a metadata pool, and we're authorizing a keyring, and we start the MDS service on whichever machines you wanted. iSCSI has its own keyring, so we authorize that keyring, distribute that keyring to all the iSCSI gateways. LRBD is still being used to sit there and create the redundant gateway configuration. The configuration's imported, and the LRBD service is started. Rados Gateways seem simpler at first, and then there's an extra hook to it. We're authorizing a keyring and starting Rados Gateway. Sounds about as simple as it could be. However, because of some of my peers, found out that one of the issues that we have is customers who want to run multiple Rados Gateway configurations, or in some cases, multiple Rados Gateway services on the same node. So one of the things that we've got set up is that you can actually create your own roles. So for instance, the silver, gold, and platinum, you could create those as Rados Gateway configurations and then make the modifications to a silver version, a gold version, of a platinum version of the ceph.conf. And do exactly what you want to do, which is you don't want to have to manage all those files and all the minions, or even the right minions. You just want to make the smallest changes possible, specifying the port number or whatever controls you wanted to put in place, and then let Salt do the rest. And that's really the end of stage 4. Now, the one additional thing here is, in addition to the higher level orchestration of just saying ceph.stage.4, if you're sitting here working through this and you want to just test iSCSI, or you're just wanting to run the iSCSI, or you're just wanting to run the Rados Gateway, I made separate orchestrations for those. And role removal. So this is the 5th and final stage at the moment. And this takes care of the opposite. Oh, question again, sorry.
Still about stage 4, sorry.
Yeah, it's okay.
About the authentication, do you have anything in place that takes care of authentication for iSCSI or Rados Gateway, or do you have to do it manually if you want to have users or specific keys?
Are you referring to the whole iSCSI authentication, many authentication schemes, and basically the target CLI calls? And yeah, so we're using LRBD at the moment. So lrbd.conf is the thing that drives that configuration. Do we have a nice editor for it? No. Yes, believe right behind crushmap, that would be the other thing to work on. Now, there's some talk about what we should do there, because part of the belief is that maybe we should put it in OpenATTIC. On the other hand, the SES 5 talk roadmap is going on right now with Larry, our product manager, and I'm sure he's going to have a huge laundry list for the OpenATTIC team as well. So we'll figure it out. But yes, at the moment, I create one by default that's very simple, but it is text editing a separate configuration file at this very second. So yes, you can do it, but I would say look at the LRBD website. Let's see, so role removal. So the whole idea is you have storage machines you want to pull out of your Ceph cluster. You have a Rados gateway you've decided that machine started to act up and you'd like to pull this out. It'd be nice if you didn't have to do that stuff manually, and that's what this takes care of. Effectively, it updates the mines first. This is taking care of the issue that if you've gone back to your configuration right there between stage 1 and stage 2 and said, I don't want to include these machines doing those things anymore, then this makes sure that that gets updated. The first step is to remove monitors nicely in case that you've got a machine that still thinks it's a monitor, Ceph still thinks it's a monitor, but you have decided it's not a monitor anymore. The next one is empty OSDs. Now, if you have no data on your OSDs for the storage node you're subtracting out, it's really not going to take too long. If you have significant data sitting on these, so this part is going to be a variable amount of time. Effectively, what I'm doing is I'm reweighting these down to 0 so that all the PGs move off gracefully for Ceph, and only then does the process continue. So just be aware of that. The resend role. This is the generic Salt cluster of SLS files that goes into each minion and effectively does the undo. Unmake that as a storage node, remove any configuration from it, unmake that as a monitor, get rid of the configuration, stop the services. That's what the resend role does. The last two, remove CephFS and remove RGW. If you have completely removed CephFS from your configuration, then the last thing to do, since we automatically created the pools, was to go ahead and take those pools out. And the same thing with RGW, at least the default. If you sat there and said, hey, I wanted to try out RGW, I'm not going to go with it, you subtract it out, then we'll go ahead and pull those pools out. But just like everything else, if you don't like that behavior, you can disable it. And actually, I just sat here and ran through that on the pages without having to flip the screens. Okay. All right, so at the end of the role removal, sorry, there's the orchestration file, and it's the same command again, ceph.stage.5. All right, so that's it for the stages. Everybody's good with that. Let's see how we're doing on time. 10:40. All right, so the policy.cfg. All right, so I said there's one magic configuration file where you put things in. At the moment, it's manually crafted. This would be one of the other items because we have multiple opinion solutions on how to make this easier. But for the sake of automation, for the sake of administrators comfortable with text files, this seemed like a decent start. So in essence, I cannot remove the complexity from Ceph. It has enough flexibility, enough different configurations, but the good part was could concentrate or focus this all in one location. Now, some of this, you guys realize that if you have a 24 drive server or 36 drive server, and especially if you have mixed models, 18 and 6 of spinners versus solid state, you've got more than one answer there that you can create as far as a viable Ceph configuration. And trying to go through and create all these permutations or combinatorial factor, that we'd end up for your particular hardware would be almost insane. Because if, especially in certain hardware configuration or hardware chassis, you could have a very significant number of configurations and the noise would just be, you probably would not be able to find the configuration you want in that noise. But then the other idea was, rather than you having to edit and sit here and specify everything that you wanted one at a time, that multiple choice showing you the different pieces would be easier than having to fill in the blank. So the first example, and probably the easiest one to understand, is role-based host names. And this is a policy.cfg. So I'll go through each section, but you can just see that there's effectively just comments, 4 sections, a cluster assignment, the hardware profile, a common configuration, and the role assignment. So the first one's cluster assignment. And you can see that it has 2 lines there. And effectively what's happening is this. During that discovery phase, you have a bunch of machines in your network. I don't know which ones will be monitors based on their name. I really don't. But all of them could potentially be monitors. So in a sense, what I do is I go and create, well, I'm sorry, I'm getting ahead of myself with role assignment. In cluster assignment, you have all your Salt minions. Any or all of them could be in your Ceph cluster. I don't know what you want. So by specifying in the file, effectively just globbing and saying, hey, would you include this file? And the contents of that file is cluster:/Ceph, then I know, oh, this machine is actually supposed to be part of the Ceph cluster. Now there's also a cluster unassigned, and you'll notice I put it in purple. This is not included because of the 2 lines you see highlighted in green there. But the client, on the other hand, is. So this is one of the important things about the policy.cfg. Successive lines overwrite the previous lines. So if you wanted to whitelist and just simply specify each machine in the configuration file, you could. But if you want to blacklist, because chances are, if you have 50 minions in your Salt cluster and 48 of them you want in your Ceph cluster, it's probably easier to subtract the 2 that you don't want. So the easy solution for that was create a cluster called, or it's not a cluster, just say it's unassigned and it will not be included in your Ceph cluster. I'll skip the hardware profile for just a second and go to the common configuration. The common configuration is holding things like your FSID, your public network, and your cluster network. That's about it. The whole reason there was these are the pieces of information you're going to need for Ceph. Chances are these are things you're not too interested in changing. One exception might be the public network and the cluster network if you feel that those were wrong. The next piece is the role assignment. And you can see what I've highlighted there is the role admin for monitor, the role mon, and the role MDS. And that was just to show you that it is globbing. It's just shell globbing like you normally used to. So that in this case, I'm saying that these machines that match this glob, I want them to have an admin key. I want them to be monitors. But of the ones that would be mon1 and mon2, I want them to be MDS as well. And just to show you really quick behind the scenes what's in those files, is in the role admin, you can see that the file just contains the YAML that says it's an admin role. Likewise, the role mon contains the mon role. And lastly, the MDS role. Now you can imagine what's going to happen here. When you sat here and specified this, that stage 2 we talked about earlier is simply combining all these, and all these roles will get put into a single file and put into the Salt pillar. There is one special line there, though, for the tail end of that, and that is because the ceph.conf needs the IP addresses of the monitors, that has to be included as well. These examples do exist in the package. And now to the hard part of the topic is the hardware profile. Let's see how I'm doing, 1046. All right, so you see this profile, 2 disk, 2 GB, what in the world is this? Effectively, we'll talk about the label of it in a second, but these are hardware profiles. Chances are the same hardware can be used multiple different ways, especially in the case of different spinners and solid states. But basically speaking, I do need to know whether you want that machine, that Salt minion. Do you really want it in your cluster? If so, star.sls will match all the machines. The second line is effectively showing the breakdown of the data structure. Did you want dedicated OSDs for each device, or did you want data plus journals? In other words, are they separate? Now, you're not typing any of this in, just so you know. So figure these are the first things that just came to your mind. What about real hardware? Why is it named that way? What about the real device names? And what about host names that are not role-based? All right, so the first thing. It is really hard not knowing your hardware ahead of time to try to communicate with you. But one of the things I'm fairly confident about sysadmins is they either know the models of the drives they've got, the size of the drives they have, and maybe even the quantity of the drives they have. So chances are, if they've got 3 RU servers and there are 24 SATA drives in there, if you see 24 HGSTs, 10 terabyte, then you probably know which machines those are. In fact, you would know that's what you intended to use them or how you intended to use them. The -1 at the end there is simply a profile. In other words, in the case of, let's use a 12-disk setup, maybe 10 spinners, 2 solid state. The -1 will typically be, all 12 of those will be individual OSDs. But a -2 will also be suggested to sit there and go, well, you could take the first 5 of those and put partitions on those solid states and make those journals. And I'll do it that way for you, and then take the second 5 and put it on the second journal. And then that would be the -2. The bottom one is a real example of if you have enough, that SATA 29 gig was supposed to be a second OS drive for one of our machines that we have in our lab. So if you have hardware that appears that you didn't want to be included, there's more than one way to solve it. But for the most part, I ignore any drives with partitions. So if you really are saying, use this equipment, don't use that drive, even though this is a storage node. If it has a partition, I will ignore it. And that's probably the simplest method. All right, how does that look up there? So what do real drives look like? Because the problem with virtual hardware versus real hardware, you can't use SDA, SDB, you reboot, discovery is a different order. You don't need OSDs moving around like that. So I'm actually looking through and grabbing the by ID. So you will have the real device names. And that's why, for the most part, I feel you do not want to have to type these in. But you'll notice all of these are listed under the OSDs, and the data plus journals is empty. So you can tell by looking at this that this suggestion says, oh, every one of these would be a standalone OSD, including the 29 gig drive. So you may not want this, but I thought this was a decent example configuration. This one might be a little harder to read. I didn't know how the font size would come out. But effectively, you see the data plus journals. What it's doing is listing, just as I said, like if you had the spinners. In this case, we have solid states and NVMEs. And the NVMEs are going to be journals for the solid states, because why not? So the first line, or the first part of each pair, is the data drive. The second part is the journal. And by defining it like that, the rest of the salt state will take care of the assignment for you. Now, the nice thing about this is you could see that this exists in a file something like, what I call it, d1.ceph.yaml. If you had data nodes, D1 through D20, each one will have their own ceph.yaml. Each one would have the same exact structure for the hardware because they have it, but they'll all have their devices in there. So that way, each machine will get it set up identically according to the behavior that you specified, if you wanted it. And okay, so that's it. Any questions for that? Because I know that was a little deep and a little fast. All right, if we're good on that. So one of the problems, I just showed you role-based host names. If you're looking at role-based host names, you say yes, but what happens when I'm using OpenStack? I'm doing cloud. What happens if I'm in somebody else's network and they've named their host? I can't change them. Or the hosts, there's no rhyme or reason to what the hosts are named. So if you're familiar with Python, you're familiar with slice, I added that as well. So this way you could do globbing. And if all your host names are effectively interchangeable, but maybe you're setting up a cloud environment and you just wanted to bring up and say, hey, you know what? I'd like these three, just, 2, 3, and 4. I want those to be the monitors. Then here's another way to sit there and specify them. That way, you could be specifying by index, and that may help at least a couple groups of people. Lastly, If somehow role-based host names and indexing effectively do not satisfy, I even added regular expressions, and like you see, you can actually have a glob followed by an RE followed by a slice so that you could do regular expressions. If you're doing this, I would actually honestly like you to write me, just because I'd like to understand your environment. But I effectively did this because see if somebody was in this situation, is that if indexing and role-based host names do not match, then regular expressions will probably pull you out of the sticky wicket you're in. And I originally had titled this and OpenATTIC because I had other impressions when we were first starting this. However, Lenz is here from OpenATTIC, and he's giving his whole presentation. So not to steal his thunder and not to have screenshots in here, I effectively shortened this part of it. OpenATTIC. So at the time that I wrote this, they were with IT Novum, who are our partners. And as most of you know from yesterday's announcement, they're actually SUSE employees now. It has a customizable dashboard. It creates, removes pools and RBD images. It displays OSDs and minions. What it does not do yet, it does not deploy Ceph from scratch yet. And the intention is for it to use Salt, in other words, this project here, to add and remove roles. We're trying to make sure that the command line that I just took you through and that the GUI are following the same exact path, and that we don't end up with two different implementations that drive you nuts because you're trying to figure out why does this work in the GUI or why does this not work in the GUI. But neither one of those are here quite yet. The actual goal will be, it would effectively be rerunning stages 3, 4, and 5 in most cases. So you'll already know the magic behind the scene. And the name of the project is called DeepSea. And it's actually on GitHub. So if you want to, DeepSea seemed like a decent name. Most people could spell it. It's where we, there's enough cephalopods. Contributions are welcome, but we'll be trying to keep as much of our issues on the GitHub issue tracker there. And you can see our active contributions that we're doing right now, as well as keeping OBS updated with an RPM that is the latest and greatest. But this is also part of SES 4 and will be available on December 1st. So if anybody have any questions? Or, in the back.
About updating the cluster, let's say SES 5 comes around, can you just update the repos that these used to install on the repos projects and rerun the...
That'll be our goal. Is actually right now our update process is written by one of my peers who's sitting here in the audience, and it is an outside process at this very second between SES 2.1, SES 3, and to SES 4. Between SES 4 and SES 5, our goal is to sit here and pull that update process into Salt itself to where, yeah, it'd be trivial for you. Because some of the other things that we're talking about for SES 5 are things like Blue Store. And the goal here would be for you to be as lazy as possible, in the sense that, yeah, I'd really like to use Blue Store and not really be interested in going through each of my OSDs one at a time and recreating them. So, yeah, that's on our list. Any other questions? All right then. Well, I think I actually finished in time, and thank you for attending.